So my name is Craig Werner. You'll have access, I believe, to all the slides we're going to produce, as well as the audio that goes along with it, as well as the mouse movements and any clicks or circles or points that we do. So this will be accessible to you afterwards. You don't have to take copious notes. They're available. So Stephen, said my background a little bit. I'm from Werner Company. That was my family business. I spent my life making aluminum and fiberglass ladders and all the components that go into that, which is a lot of aluminum extrusions. So I've been associated with aluminum extrusions for the last 30 years, and with designing products out of it and products, as Stephen said, that you rely on those structures every time you or your family or friends of yours or workers go up on one of these ladders. You got to be safe. And in solar, it's not just the cost of the material, but it's the total installed cost, and beyond that, it's the total operational life, the total operational cost, total cost of operations, which really matters, and that's what's going to drive success. Short-term, purchase price may be something that people focus on, but pretty quickly they recognize that's not just it. So I'm going to talk to you a bit about the aluminum extrusion industry and its use in solar, and I think you'll see some interesting facts here. I'm going to go buy some of this material very quickly, but I told you it's going to be available on the website because then you don't have to try to take notes, and you'll also notice I skip by a few things. So while I have my own business now, the Werner family sold the company, and the new owners moved all of our U.S. operations to Mexico, and I elected to stay up in the Chicagoland area. I basically do two things. I consult with aluminum extruders on optimizing their operations, and I also work on designing structures out of aluminum extrusions and working with companies that may be very familiar with steel but don't know a lot about how to do the detailed design using extrusions, and because that's what I did my whole life with ladders, I'm pretty good at that. But the other thing I do with about a third of my time is I volunteer for the Aluminum Extruders Council, and that's what I'm doing here today. I'm volunteering and I'm representing the aluminum extrusion industry to tell you a little bit about us. The contact information's all there. You'll have it, again, accessible to you. So I'm going to talk briefly about extrusion. I'm going to talk about two independent studies that were run, one on PV and one on CSP. CSP will be real quick. And then I'm going to open it up to questions. Aluminum extrusions are really cool. You're going to see shapes here. When you think of steel parts, you're usually thinking of C's and L's and I-beams and channels, very limited number of things. But as you all know from walking around the floor, there is an endless and infinite variety of things you can do with aluminum extrusions. And it's that flexibility that lets you design things that are interesting but functional. And that's what we're going to spend a little bit of time about. So a lot of times, with steel, you're faced with trying to figure out how to fabricate and assemble something and join it together. With aluminum, you can build these features right into it. And it's very easy to combine the capabilities of the aluminum material with the aluminum process to get something that really represents an ideal way to build a product. Not always, but a lot of times. Aluminum is strong. It's got a whole bunch of great advantages, three of which I've highlighted in red. It's got a tremendous strength to weight ratio, and it's corrosion resistant. And I think those are three things that we would say in structures needed for long-term life for solar applications. Those are three nice attributes to have. Aluminum extrusions, when you take the aluminum and now you fabricate it by the extrusion process, they're very easy to fabricate. They're easy to design. You can join them by different means. They're suitable for easy assembly. You can produce them to close tolerances with great quality. This isn't something new. These extrusions have been out since, I guess, the 40s, maybe even a little earlier than that, but commercially since the 1940s. It's not a sexy new product, but it is a product because we have an infinite variety of shapes that we can make, that it's a wonderful product for designers to use to optimize whatever the next thing they need to build is. This is an example of a robotic arm, but if you look at that, if you try to picture building this out of something else, this piece would be typically extruded out to maybe 100 foot in length and then cut off into what length it needs to be used in this case, it's relatively short. But we can build features in, heat sinks, connection means, strengthening ribs, all those sorts of things are built right into the part. So I think Stephen referenced the fact that, some of these aluminum parts, they do double duty. They may not just be structural, but they also may be doing some other function that you need. The other thing extrusions are is they're extremely cost effective. And they're cost effective, again, because of the flexibility, but also the tooling is very, very inexpensive. I mean, you'd be hard-pressed to spend $5,000 for an aluminum extrusion tool. Most of the solid dies you can get for around $400 or $500. And the lead times aren't measured in months, they're measured in weeks. So if somebody comes up with a new shape, you can do prototyping and test things out pretty quickly. The features you can build in, I am not going to try to talk you through this shape and show you all the little doodads you can do, but this is just a sample that Werner used to give out to people so that they could dream about what are the things that I can build into an extrusion. You'll have that accessible to you afterwards. Tooling is very simple. These things are actually sitting in my office. They're yay big. They're somewhere between $500 and $5,000 depending on what you're buying for the tool. And extrusions aren't only structural. Of course, they're very good at heat sinks. They're very good at dissipating heat. So for the inverters and other things, other components and CPV, it's certainly used a lot. And these are just a couple of pictures of extrusions I'm going to bounce up on the screen to just kind of show you. They can be simple tubes, they can be complicated shapes, they can have screw bosses built in them, they can have all kinds of features. So extrusions, in general, are strong and efficient, and they're really creating long-lasting structures that are critical to our future. So, I've got aluminum ladders. I made aluminum ladders. My plant made 3.5 million ladders a year, and I've still got the ladders leaned up in the back of my garage that my father gave me when he was done using them. They last forever. Fiberglass is a great product. Werner makes fiberglass ladders, but they're affected by UV over time. Aluminum, you see these aluminum ladders on the top of people's trucks, workers' trucks, they're there forever. And that's what you want out of solar components too. You don't want to balance a system that you have to maintain. So the aluminum extruders industry hired IBIS Consulting, which is an MIT group, ex-MIT group, which goes out and looks at strategic material choices. And we had them do 2 independent studies. And by independent, I mean they really were independent. We weren't guiding them. We were telling them, we want to understand how we compare to steel. So they looked at PV and they looked at CSP. I'm going to first talk about the PV study. In the PV, and this is the IBIS contact information, which is also in there. Their goal was to look at some of these installations in everywhere from residential rooftop to commercial flat roofs to ground mount utility scale, anywhere from 1 to 5 to 50 megawatt systems. They wanted to understand what the cost drivers were. Again, not just the purchase material, that's easy, but what the total cost is of putting in one of these systems. So they contacted different manufacturers and distributors of these parts. They contacted the people who do the installation. They actually looked through videos that were available, and these are IEs and engineers out of MIT. They also did some time studies on it to verify it. So they took information from a bunch of different sources and brought it all together so that they could compare all the information and come up with an accurate cost model. They didn't look at land because it's different depending on where you're installing things. But they looked at, for aluminum and steel, all the different costs: procurement, extruding it, fabricating it, shipping it, subassembling it, assembling it, and they even looked at the recycling cost, the recycling value that would be applicable someday. I am not going to go through the details of these studies. They're here on the slides. I'm going to flip through them. You'll see what they are. But I'm going to take you right to the conclusion because I think the other gentleman would like to have a chance to speak as well. So here's a commercial flat roof and some of the particulars of what they did there. We've got some information about, the spacing and the number of modules and the spacing between the different steel or aluminum components. Here's a system where we're looking at, there we go, for aluminum and for steel, a small ground mount utility, a medium ground mount, and a large utility. And this is kind of what makes those things up. So this is the basics. We're building up from what are they looking at to what does it mean. They looked through, they talked to different equipment manufacturers, different suppliers of these systems, and they got listings of what the parts were that go into them. They have their own cost models, but they also use what the pricing they heard from them. And they eventually came up with what is the cost of all these components, as well as I said, the installation, shipping, and everything else. So the bottom line, if you look at a study like this is showing for aluminum PV mounting structures and for galvanized steel PV mounting structures in residential, commercial, and 1, 5, and 50 megawatt fields, what the price is. I'm just going to focus on the utility scale fields here. You can look at this on your own. But you can see the aluminum ranges from 19 to 25 cents, and the steel is 21 to 25. It hits a 23 up there. Somebody in aluminum was charging 40. You guys probably aren't going to buy from them. But properly sourced, aluminum on the material cost basis is very, very competitive with steel. But it's more than just the material cost, because you have to look at the installation cost as well. And the installation of the aluminum versus the steel is less. If you were charged with putting these things up on a roof or putting them in a field and installing them, steel's heavy. Sometimes you need a crane, sometimes at least you need two guys. A lot of times with the aluminum things, particularly the individual parts, it's easy to grab in one hand with your tool in the other. And it sounds simple, but we made 3.5 million pounds of aluminum ladders and fiberglass ladders, and you build them up out of a lot of small components. And that's what these solar fields are built out of. So when we look at those costs, we see that for the utility scale, again, the costs are fairly comparable, 36 cents per kilowatt, and, actually I think this is per pound. It's a similar cost, aluminum to steel, but when you start to look at shipping, now you start to see a difference. Shipping costs of aluminum are about 0.4 cents per kilowatt, and shipping costs for steel are about 1.2 cents. Steel is heavier than aluminum. And because of this, that adds a little bit more leverage to the argument for going with aluminum. When we look at the entire structure, we look at, wow, aluminum is really, again, let's look at a medium ground mount. Aluminum is 38 pounds per kilowatt compared to steel, 99 pounds. But aluminum is more expensive on a dollar per pound basis. So actually, when you look at the costs, you might look at it and say, well, that's true, but the aluminum is $5.86 a pound, and steel is $2.12. So clearly, you're going to be better off going with steel. That's one of the messages, unfortunately, that people take out of this. And if you were to look only at the cost of the material on a dollar per pound basis, one might say aluminum is always much more expensive than steel on a dollar per pound. But you're not buying pounds. If I wanted to sell steel ladders, I could. Nobody would want to carry them, and they wouldn't want to maintain them, but you could sell a steel ladder. You buy aluminum ladders because they are very efficient, both in terms of cost, but in terms of weight. When you roll in the weight of aluminum versus steel, you find that actually aluminum is less expensive per watt than steel is. It's 32 cents to 34, 29 cents to 31. It's always a bit less expensive. So this gets back into what I was saying, the total installed cost of these systems. You got to look at the whole picture. And we're certain that aluminum presents a compelling argument to do that. A lot of times, these things are going to be mounted up on roofs or out in the field somewhere. Someday somebody's going to take these down and they're going to recycle them. I mean, we're in a green industry. We don't want landfills full of these things, and aluminum has a substantial value. So if you were to look at a 50 megawatt system, for example, there's about 2 million pounds, $2 million in current value of recycled material out there. Steel is about 600,000. So besides being a little bit less expensive, the total cost of installation, you've also someday got the recycling cost. Most people are not looking at that. But in the total cost of ownership, you've got to buy the stuff fabricated, install it, maintain it. Remember that one, because aluminum doesn't corrode. You don't have any of those issues in the field. And eventually you get to recycle it. The CSP study is much, much shorter. The CSP study of my presentation, the study was just as long. But we looked at 5 different steel designs and 1 different aluminum design. There's only one that's actually out there. The aluminum structure, $1 per unit area, which is the amount of mirrors that are supported, is just under $40 per square meter, versus the steel designs ranging from almost $60 down to $50. And when you look at this was at a snapshot in time at the pricing of aluminum and steel. And let's face it, these material prices vary. So we looked back and we said, how have they varied over the 20 years? In the last 20 years, going back to 91 through 2011, steel is in blue, aluminum is red, and the green one is zinc, and that's because there's so much galvanizing used in steel components. We felt that we needed to incorporate the price of the galvanizing in here as well. When you take all of these material components and you put it back into the IBIS model, basically it shows There was no time over the last 20 years where steel was less expensive than aluminum. Plus, you get the tremendous features of aluminum that you can build in, the performance, the ability to not have to maintain these structures because they don't corrode, and the recycling value when you're done. So we are certain that aluminum provides a compelling argument, and if you walk out there on the floor, you're going to see the exhibitors, and there's a lot of aluminum material out there. We just want there to be even more, because we know that there's more opportunities to put more aluminum product out and to make a better long-term solution for the solar industry. I'm going to leave this slide up for a minute. Do we have time for a few questions now? Or
sure.
If there are any, you can ask them. Otherwise, you can ask me afterwards. But aluminum's here for the long run. Those ladders have been out in the back of my house forever. They were out in the back of my father's house forever, and my kids will probably inherit them as well. And they're still safe to climb. And same thing will exist for your solar structures. Okay, I'm going to turn it over.